All right, 6.2. 6.2 is multiplying and dividing rational expressions. And essentially, there are a series of steps. It says factor the numerator and denominator of each expression, multiply the numerator and multiply the denominators, reduce the ratios of common factors to 1 and minus 1, and simplify. Sometimes you just hate mathematical language. It's just like, what are they saying, right? What they're saying is this. They take the original problem, they factor it. When you multiply, it makes it one big multiplication factor, big problem, because you multiply across. Remember in arithmetic, if I said 2/3 times 1/5, you multiply across, it's 2 times 1, 3 times 5, right? And that would then become 2/15. You'd reduce it down. So algebra multiplication is no different. The only difference is you've got sets of parentheses that are factors instead of numbers. So now it's one single problem. So once it's one single problem, you're going to look to see if you could reduce it down. In other words, form ones. And here's an x plus 2. There's an x plus 2. That forms a 1. And there's an x plus 7. There's an x plus 7. That forms a 1. So what you're going to be left with is 1 over what's left over, which is x minus 6, x minus 2. Simply, that's just what it is. But what I want you to remember as now we focus on the problems is this. If you have y than one term, that's a set of parentheses. More than one term, that's a set of parentheses. Additions and subtractions, set that up. Right. So now when you multiply, it becomes a single problem. So what are you going to do? You're going to factor the numerator, which is x plus 1, x minus 1. That's this guy. Factor the numerator, which is going to be, this is going to be an x minus 3, x minus 2. Here's the good news, is that the factorizations are simpler than what you had to face last chapter, for the most part. Difference of squares, x plus 4, or not 4 but 2, x minus 2, and then this is x minus 3, x plus 1. Two numbers are multiplied together to give me 3, but subtract to give me 2 would be 3 and 1. So now you look to reduce out. Here's an x plus 1. That gives you a 1. There's an x plus 1. Here is an x plus 3. See, it forms a 1. This is a nice problem. Now you're going to ask me why I think it's nice. There's an x minus 2. So I only have two things left, right? X minus 1 over x plus 2. Now remember, since that is additions and subtractions, that forms a set of parentheses. So with parentheses, either everything goes or nothing goes. And what I like about it, it didn't turn out ugly. It could have turned out, since I've got 4 factors multiplied together in the numerator, 4 in the denominator, I could have maybe only gotten rid of 2 and been left with 2 in the numerator, 2 in the denominator. That's what I think is ugly. This is clean. I'm left with 1 and 1. Cannot reduce out the x's because that is reducing across an addition or subtraction. You cannot. They're held together by that set of parentheses. You either get it to come out or you can't reduce it out. Or you can only reduce across multiplications. Again, multiplying, this becomes one problem. Set of parentheses around the individual groupings. Factoring the numerator, greatest common factor of 2, 3y plus 1. Y minus 1 is already prime. Difference of squares, y plus 1, y minus 1. Greatest common factor of 3 of y. Don't know why I did that. And it's 3y plus 1. Now what do? You go to match them up. You're playing a matching game. Here's a y minus 1 and a y minus 1. They're just about over top of each other. So those two go, leaving 1s behind. They form a 1. And then I notice I've got a 3y plus 1 and a 3y plus 1. Again, they form 1s, so they go away. Oh, this is an okay problem. I'm left with 2 in the numerator and a y plus 1 in the denominator.
So you just leave it like that?
And just leave it like that. You can multiply the through by the y if you like, but here's what happens. Lots of times whenever you're dealing with problems where you're simplifying along the way, if this is part of a middle step of another problem, when you go to do it, if you would multiply through by y, then you have to refactor in order to use it. So philosophy is I quit while I'm ahead, because the chances of me making a mistake if I don't have to do something are pretty good. So unless I need to, I don't multiply it out. However, I would mark it wrong if you did.